We briefly looked at the dialog files during the asset overview in Part 3. These files contain both the dialog text as well as the control instructions that aren't friendly with text interpreters. By the end of this video, we'll understand exactly how these files work and how we can incorporate them into the prototype. Now, as usual, we'll copy the dialog files to our workspace. Let's take a look at the top of the first dialog file. And we recognize this is the script to the game. Notice that each line of text has some control information at the start of each line. Understanding this control information is key to building our own runtime interpreter of the dialog file. Now, I think it's easier to understand if we view all of the non-printable characters as hex values while keeping the ASCII dialog. Let's do this in Python. Well, this isn't really easier to read yet, but in this view we can actually see all the control characters, including carriage returns and line feed characters. The text dump we used before tends to process control characters rather than display them. Now, if we parse this long string, we can get a view similar to the PowerShell display with substituted hex values for all characters. The best way to do this is to process these carriage returns and line feed characters, print bytes with values under 65 as hex, while printing character values over 64 as ASCII characters. Let's open regular Notepad. We'll open the file and dump the text in one line. Set up an empty buffer, and we want to build a line one character at a time and use the carriage return and line feed pair to print the line and clear the buffer. We just want to grab the first mission, so hopefully the first 1500 characters will cover it. This can be easily changed if we need to. If I were going to use this program more than once, I'd pass the byte values from the command line so we can find arbitrary points in the file without having to edit it over and over again. Now we'll program our base cases. If the value in the byte is less than 65, we'll print it as hex with an added space for readability. Or else we'll print it as an ASCII character. Now we'll move on to the special cases, which I'll process first. If the character is a carriage return, we'll print the line. Now recall that carriage return usually comes first when paired with the line feed, even though its encoded value is higher than line feed. Line feed will clear the buffer. I think we'll add something for spacebar to help with readability. We'll complete the ladder here to avoid double evaluation. Now run it. Okay, so we now see something easier to read that includes all of the code values. Looks like we got part of the debriefing sequence too, so we can double check things if we have to. We see each line comes with at least one code, but sometimes it has as many as 4. The traditional way to encode anything is to order the code sequence from most important to least important, or from primary to secondary. So if the first code refers to a function, then the next code would be the arguments for that function. It doesn't have to work that way, but it's a good way to approach problems like this. Let's try to understand the primary code sequences of the dialog and make educated guesses about the secondary codes. At the very top, we have a primary code of 6, followed by a secondary code of 1. This 6th code occurs one other time down here at the start of the debrief, where it has a secondary code of 2. Since this code appears first at the start of both scenes, let's say that the code of 6 indicates the start of a dialogue sequence, with the second code being the unique identifier of that sequence. Next, we have a primary code of 1. We see the names of the 2 actors in the scene defined here. We can't really tell the difference between the next 2 secondary codes, but at least one of them is probably the position that they're at on the screen, left or right, and the other is probably a reference to their sprite graphic. Maybe the last code is too. I think we see that the last code is also somehow associated with the actual dialogue in the scene. We see the Velasquez code has a value of 2e, and every dialogue line involving her is identified by 2e as well. This is likely a link between the speaker definition and the actual dialogue lines in progress. Next we have a code of 3, which also only occurs right before dialogue begins in both scenes. This is probably a start dialogue indicator, and it may trigger a fade-in from black. The code of 2 clearly indicates the start of a new line of dialogue. The secondary code always appears to be 1, so we can't really tell what the effect is. As we already said, the third code matches to the speaker. We can actually test this by editing the game dialog file in place and testing the outcome. Let's focus in on this line of dialogue in the middle of a long block from the dispatcher. Open DOSBox, start the game, new game. Here's the line just as we expect. Let's open the hex editor and go to the game dialog file. Let's find that line that begins with the word arms. The byte before it is 39 hex as we'd expect. Let's change it to the code for Velasquez, which is 2E. Now we'll reopen DOSBox. Now, as you probably guessed, the game processes the line as spoken from Velasquez, including changing the color and highlighting her character. Let's fix that. And while we're here, I'll verify that unanswered question about code 1. Scroll down to the first scene that has another character from other than the dispatcher. Okay, here's where the commander is initialized in the dialogue, with a 1, 2, and 3 byte. Now the 3 byte probably indicates the face number found in the faces file we extracted earlier. Let's confirm that too. Yes, it looks like the Velasquez is face 1, Dispatcher is face 2, and Commander is face 3. We now know that the third parameter defines the face sprite, starting from 1. The next code in the file is 5, and this is obvious too. It pauses the dialogue sequence after every speaking section until the player presses a key to continue. The only other codes occur at the end, both code value 4 and code value 64, which we see here as lowercase d. These codes always end the scene in pairs. 4 probably indicates the end of the scene and possibly the fade out trigger, and 64 is probably the trigger to return control to the calling function, either to go to the game or the main menu or whatever comes next. So now we have an understanding about how the dialog file works, and just like the map files, we don't have to make any changes for now. We'll use the dialog files as is when we prototype. Next time we'll try to figure out the mission script files.